3. This is the VC Forum. My name is Sachin Desai. I'm a storage architect at Avalanche Technology. It's been programmable technology, and I'm on the system sides for the group. A lot of people ask me, why do you do the VC part? I don't have a finance or an MBA background, but I argue that if you're an engineer, you really should know your market, because your market is your customers. If you're building something, you better understand where the money and the money flow is coming from. Today we have a full panel because of a little bit of the table mishap. I'm going to be the voice of God behind talking to them, but they're primarily talking to you. We're going to have a Q&A for 15 minutes towards the end. And if you would, can you please silence your cell phone? Even if you think you've silenced it, please try and silence it now. And with this, I'll let the panelists introduce themselves. We can start off in the far right. Introductions, yes, please.
Okay. So my name is Brian Wilkove. I'm a partner at a firm called Artiman Ventures, based here in Palo Alto. We're an early stage fund. We focus on what we call white space investments. So we look for really big markets, so kind of 5 billion plus, with little or no competition for our portfolio companies. We tend to be pretty active investors. We manage maybe about $1 billion today, and I've been in venture for about 15 years, and before that I was in the carrier business for about 10.
Hi, my name is...
Be careful with your chair.
It's almost at the end.
Yeah.
Thank you.
Ejector seat.
Yeah, you got it.
Good afternoon. My name is Chris Rust. I'm an early stage investor. Investing my own money, which is a lot of fun. I've been doing early stage venture investing here in the Valley since 1998. Was a founding investor in a number of companies related to this conference: Mellanox, Dune, Abrizio, more recently PlumGrid, and then SDN Arena. And so I have a real affinity and soft spot for the topics that I covered here today.
Hey, I'm Alex Bennick with Battery Ventures. We're a stage agnostic investment firm. We manage about $4 billion, early stage, growth as well as some late stage. Personally, I'm very early stage oriented, focused on infrastructure technologies. We've been investing in networking for 30 years, going back to, Banyan Vines and Four and Redstone. More recently, companies like VSS Monitoring, and I'm on board Cumulus. I know Dinesh spoke earlier. So thanks for having me.
Hi, I'm Kambiz Hushman. I run an incubator in Palo Alto. We get involved extremely early, when in fact most of the time the company is not even formed. We have 13 companies in our portfolio, mostly focused on mobile so far, turning our attention now also to the impact of IoT and context computing space. Prior to doing this, I was at a public company. I was the CEO of a public company called Applied Micro. And prior to that, I was at Cisco for 10 years, making carrier class switches and routers.
Okay. Good afternoon. I'm Jeff Lipton, and thank you for having me. I'm at Juniper Networks. I've been there for 5 years, and I run our investment program. We have 2 investment funds, really. One of them is called the Junos Innovation Fund, and that focuses on early stage software that intersects with the Junos ecosystem, the Juniper ecosystem. And the second fund we have is a pretty plain vanilla strategic fund. We invest in hardware and componentry and special situations that help our business. We've completed 31 investments over the last 5 years. We've had 13 exits. 2 of those exits were in the SDN space, Contrail and Nicira. Those are both my investments. And other than that, a lot of our investments are undisclosed, but we don't have any other investments in the SDN space, but we do continually look at the space and related spaces as well.
Good afternoon. My name is Angelo Rantia. I'm here representing SKTA Partners, and we are a seed fund and an accelerator here in Sunnyvale. We actually are very new. We officially incorporated April of last year, and we opened the doors to our accelerator in the end of January. So far we have 3 investments. We focus on core technologies, which is everything from the nanomaterials all the way out to and stopping right before the consumer-facing applications, so semiconductors, networking, telecom, etc. One of the differences between our strategic fund, our model, and other models is that although we are funded by SK Telecom, we don't invest just for SK Telecom or the SK Telecom affiliates. We can invest for anyone within our ecosystem.
Thank you, and welcome all of you. Ethernet Summit, if you were to, careful, we don't want any injuries here on the panel. With the Ethernet Summit, it's been a long time since Metcalf in, wasn't it 71 when he wrote the memo? And we've come a far way from that. But if you go out today and you look at Ethernet, it doesn't look anything like what it was back then. That is obviously progress, but if you were to now take this point forward into the next 10 years, what do you feel Ethernet is going to look like? In other words, if you're looking for investment opportunities, and if somebody were to say, I have an Ethernet company, what would be the answer that individual wants to give you in order to even listen to this person's proposal? And anyone can pick up the flag and just toss the ball, and if you want to keep it easier, we can start on the end, Brian. Either which way. Yeah, I know. Almost.
So what do you think?
Yeah, exactly. Wow, an Ethernet company. I mean, this is a technology I think that's headed for more and more commoditization, especially on the hardware side. I think the opportunity is probably on the software side, whether that's in control, and I find more interesting areas around application virtualization, riding on top of Ethernet infrastructure.
Amiel, you tend to go directly into the semiconductor and like the million, seed fund area. What would Ethernet company, would it be like switching? Would it be more software? What would draw your interest?
That's a tough question. I really don't have much to add. I think it's kind of something that's fairly mature, and finding an innovation in that area is going to be very challenging. So it'd probably come most likely on the software side more so than anything in the semiconductor realm that I can think of.
So I could see finding companies that use Ethernet as a basis for their product as being very interesting. So, obviously Arista is an interesting company. There are a few companies right now that are designing even ASICs that use Ethernet, but they do other things as well. They may have hooks into software that are unique, or different ways, as Brian mentioned, of doing application virtualization. So I think those are interesting, but Ethernet itself as an investable market, it'd be pretty hard. It's a pretty mature market, and I think you really have to have a different take on how to address that market. The flip side is that it is, last I looked, Ethernet switching is about a $22 billion TAM, and there's certainly an opportunity to address a big market if you're playing in that market. But I think it has to be something different and not just an Ethernet investment per se.
Go ahead, Alex.
Yeah, I was just going to say, right, Ethernet's going to continue to chug on, right, not necessarily incremental, but the next bumps in performance. But, I think it's unlikely, right, that we're going to invest in, physical layer components, optics, things of that nature. On the other hand, right, most interesting things in technology now, or the way modern applications are developed, are as distributed systems, storage, everyone wants to talk about scale out. That's a distributed system. Databases are turning into distributed systems. In between, right, what some people don't always forget is in between those nodes in that distributed system is an Ethernet cable. And so really having a profound understanding of networking and its impacts on, a number of other, layers of the stack, I think is only going to become increasingly important over time. So I'm not probably going to make any Ethernet particular investments, but knowledge and understanding of Ethernet and networking at layer 2 and layer 3 is going to continue to be extremely important.
I guess I have perhaps a slightly different view. I think we're going to see tremendous change in Ethernet over the next 5 to 10 years. As a horizontal technology, I agree with all the other comments of the panel. It's data link framing, L2 technology. However, if you look at the demands that are being placed on warehouse scale, computing and so forth, I believe we'll see much tighter integration and collaboration between the application layer and the data plane. And there's an unmet need perhaps for next-gen silicon to deal with setting up and tearing down hundreds of thousands, even millions of individual flows, being able to apply fine-grained policies against those flows, and And so at every layer of the stack, I frankly see unmet needs. Now, does it mean that there's a good opportunity for an early stage venture investor to take on a billion gate transistor program to build, a 5 terabyte switch? If you have enough resources, probably there are some programs like that that are looking for funding. But if you look in terms of taking SDN to the next level, there needs to be very close collaboration between, as Brian said, the upper layers of the stack for fault isolation across the stack, predictive analytics, better instrumentation to provide a better data set to drive those application-aware networks. And it's going to be fun. It's going to be a lot of fun. Lots of great problems to be solved.
If you're looking to build a company, you can still build a company in Ethernet around IP, particularly as we go into 400 gigabit and terabit. But generally, I would say that VCs wouldn't invest in IP companies, so you'd have to self-fund that and self-grow that. And sometimes not having a VC on your board is fine. You can build a company around IP.
I asked this question because that's usually the answer that, when you have a mature technology as far as innovation is concerned, you're sort of limited by legacy. But it always leads us to this thing, SDN. We've been trying to define SDN for the last few years. Do we feel SDN sort of, at least in the current reincarnation, has cemented as this is what SDN means, and everything else that's now software defined A, B, C, D, whether it's storage, security, have we passed the SDN? Are we now ready to go into something new? As the networking market, as far as the SDN is concerned, where Nicira came in, are we now into Internet of Things? Are we now into software-defined storage, lines of learning? Virtualization is now kind of breaking down any barrier you have between what looks like a network node and a storage node. We're bringing in latencies close and closer to the CPUs. So as SDN, is it morphing into something else, or are we still not exhausted the capital available in something in what SDN switches would be defined as today? Anyone wants to take the mantle?
Yeah, really nice.
You have a gift for you for sitting on that end.
Right, that might be better. There were several questions in there, I think.
Exactly. Pick one and run with it.
Yeah, pick one. So are we in agreement on what definition of SDN is? I don't think, I'm still confused. I've been in this industry for a long time.
It'd be easier to list companies that are not claiming to be SDN.
Yeah,
than
exactly. Yeah. So yeah, I don't think there's any. I mean, a lot of people equated it to OpenFlow early on. I'm not so sure that that's really the case. So I don't think we're at the point where we're in agreement, and I think that's causing also customers to delay deployments or at least slow it down because they look at so many different technologies. Everybody's got their own twist on it, so it just takes a little bit more time. Maybe it'll get there in another 3 or 4 years, but it's certainly not there.
So we certainly, as Juniper, we have what we view as SDN, and I think the concept for us is to take what really works for our customers and retain it, things like reliability and scalability, and fix the things that need fixing, right? So right now, and I think there's also a distinction between enterprise and carrier SDN in our eyes. But if you take carrier SDN, for example, our customers, which are the large carriers, they really need an ability to be more agile, to compete, to put services on their network very quickly. So that's really the problem we're trying to solve, is more agility, updating the equipment more quickly. They're actually fairly, when you think about how these things are actually instantiated, they're fairly mundane, but they're very helpful and they save a lot of money. So that's how we think of SDN. And then as far as the implementation of SDN, we think of it more as, so obviously years ago, ourselves and other companies separated the data plane and the control plane, but now we think of it in terms of a management plane and an applications plane as well. And in our view, you centralize everything except for the data plane, and that is a way to add agility to the network. So I know you could probably poll 50 people and get 50 different versions and definitions of SDN, but that's sort of, those are some of the key points that I like to think about.
So in the question, there was a mention of software-defined storage. As you know, our industry and our community loves labels. It's really not about the labels. If you look at it from the enterprise IT perspective, what's happening is that over the past 10 years, storage has become application-specific, so that you have one set of storage platforms that run OLTP, and another set of platforms that run a different set of applications. And this has led to the balkanization of storage in the enterprise, which has made the management and the capital depreciation a major, major problem for the enterprise. At the same time, the number of applications are exploding, and the number of media types are exploding. You have hard disk drives, you have different types of flash, SLC, MLC, TLC, you have cloud. So the real problem that needs to be solved is how do you create a scalable storage solution that runs over any media and applies any SLA to any application as the application requires it on a dynamic basis. Whatever you want to call that, that's the enterprise problem, and that's the problem that has to be solved. And if you call that storage-defined, software-defined storage, that's fine with me, but that's the real problem. And it's not an easy problem to solve, but if you want to go start a company, think about that problem.
Just like you folks mentioned, SDN is a difficult thing to define. Can you imagine the customers sort of being confused by this? So how do you help the companies that you invest in help the customers understand what needs to be done, or what is, they have a problem they don't know, you have to illuminate it to them. So what do you help your investment companies with in order to get the customer base to understand this is what the product does? Because it's
here in the back of the room.
okay. This is a little better. It's not better.
Sanjay, just go closer to the microphone.
Check, check.
Much better.
So in order to make customers understand, what do you do? Do you have a custom, for every product you're going to have a custom pitch, or are you able to kind of give them a general idea that this is what, because in every portfolio, all of you folks have had SDN investments. And so when you go out and you try to help them understand, how do you help them understand?
Well, I think the key is, right, customers don't buy products for architectural purity, right? Or because it looks really nice on a whiteboard, right? They buy products that solve a particular business problem, whatever that problem is. Is it the cost of your, layer 3 network? Is it your inability to access data to do analytics and monitoring? Is it, virtual machine mobility, across layer 2 domain? Whatever it is. So having a debate about the definition of these terms, is kind of senseless, right? When you're a startup, you got to go talk to customers, find a customer pain, hopefully one that has high value, and engineer a solution to meet that pain. And so, you might start off with, in a customer pitch with some high-level discussion of industry trends and all that, but at the end of the day, customers don't buy SDN, they buy solutions to problems that they have. It's really, actually fairly straightforward.
I'm glad I'm trying to box you in and trying to get out of it. So with this getting out of those definitions, what do you see in the market today as the next big driver for investments for yourselves? Everyone here has different size portfolios that have different investment strategy. Again, we're going to start with you. For the next couple of years, what are you seeing? What is kind of piquing your interest?
In this particular space?
In this space, but it's, as was just mentioned, Alex is indicating that there's no labels because there's so much blurring and overlap, and the problems we need to solve need to be solved, and whether they're wearables, whether they're a personal area network issue of communications or whatever else is coming our way, we know that data is coming at a massive amount. Pipelines are getting fatter, cooling and powers are becoming an issue, and we're looking at scales we've not in a long time. So what do you see out in the field today? Because most people here are probably interested in trying to understand what's the next wave, what's the next big thing.
Yeah. So, I think most of the SDN companies in the last few years, and even the ones today, are predominantly trying to solve a connectivity problem. And I don't really find that too interesting. This is maybe the third or fourth generation I've seen in my career. We had ATM, we had a lot of different technologies trying to solve similar problems. Going back to what Alex said, I think it's more around solving very specific application problems. So this, the notion of NFV, which is basically the idea of taking these high function cards that got built into expensive routers and splitting that back out. There's no need for that stuff, I don't think. I think, if we've got a connectivity layer, very high speed connectivity layer that's separated from the application layer, that's the interesting area for me.
I guess I have a slightly different view. If you look at the evolution of SDN, it started off as solving a connectivity problem with VLAN scaling limits, but the drivers have been more control over the infrastructure by exposing the data plane. The goal is more agility, more application awareness, more hardware options, lower cost, lower TCO, and really a rich palette of opportunities for software innovation on top of best-in-class hardware. Now, one of the things where I think there's an unmet need and where perhaps SDN and OpenFlow didn't get it right, early days, folks that were pushing OpenFlow viewed Ethernet switch manufacturers as providing generic commodity. And the data planes and switches differ dramatically in terms of their traffic management capabilities, their prioritization capabilities, the way they deal with ACLs and so forth. But I think we're in very early days of SDN. And today, when people talk about SDN, they're talking about within the confines of one data center, largely. How do you interconnect SDN instances across the wide area in a coherent way, right? There's actually a historical precedent which has been extremely successful, and that's the SS7 network, where the control plane was decoupled from the switching and the data plane, if you will. And there's still innovation which is happening in the SS7 network, even though much of the voice traffic has gone onto the internet. So I think it's very, very early days when you look at this really being a paradigm shift to create a new control plane, not only between islands within a given data center, but across the WAN and eventually across the globe in a time when we have many, many megatrends that are just putting the whole stack up for grabs.
I'll piggyback on those comments around SDN and NFV that, in my opinion, I think SDN and NFV will be first in large scale implemented in telecom networks, not in the data center where we've been focused as a community. The reason for telecom being first is, one, they have the resources to implement the management infrastructure, the human management infrastructure around this. The second reason for this is that the telecom guys actually are in a margin crunch. We all know that most of the revenue is disappearing on them in terms of voice, in terms of text. You've all heard about WhatsApp and the $19 billion price. There's 5 or 6 other companies. The text messaging as a revenue base is going away. Voice over IP is replacing voice. So they have a margin compression issue that they need to address with a different architecture. And related to that, they need to develop a different architecture where they can actually service differentiate between their customers, between their different wireless customers. So I think that's where it's going to happen first in large scale, not in the data center. That's my prediction, and I'm sticking by it.
I think Google would disagree. Given
Clearly,
that they have one of the most progressive SDN implementations on the planet.
you can count those kinds of implementations on one hand.
Yeah, but they're different problems, though. I agree that the carrier networks have, I think one of the things that the carriers would tell you is we see that Google can come up with a way, with a new service, they can dream up a new service, and they can put it on the network in no time. And if you take one of the large carriers, how long does it take them to put a new carrier out? 2 or 3 years. They want to be able to compete, and if they envision a new service, be able to put it out. That's what SDN can do. I think the data center is a different set of problems. I don't think it's a small opportunity. I think it's an equally large, if not larger, opportunity. But the opportunity in the data center is really changing trends. If you look at the number of workloads that were virtualized last year versus what the number that are virtualized this year and what they'll be in the future, the trend is pretty clear, and that requires a different sort of network infrastructure. So different set of problems. I think there is some commonality in terms of the infrastructure and the software that you can leverage to solve both those sets of problems. But they're interesting big markets.
Yeah, I mean, the advantage that somebody like a Google or Facebook, a internet service provider or, web company has, is, right, they control the whole, right, the infrastructure as well as the application, and they can use that, to tremendous advantage. As opposed to a traditional enterprise data center, you can't get SAP to implement some new feature, right? Or Oracle or whoever. So the environments are different, I think the data center is a big opportunity, I've made a bet there, I think the observation that, that we've made is that there are fewer technical issues and more economic issues, and that's really at the heart of both SDN, the data center, as well as software-defined storage or the scale-out white box storage architecture. So.
Well, actually, knowing a little bit about both the carriers and some of these content providers like a Google with SK Telecom kind of playing in both spaces, it's kind of interesting to see the way that they've asked us to look into the market. And most of what we're looking for is data center driven. Most of it comes from the more nimble aspects of the data center, and I think when we start trying to push into the carrier side of the house, they tend to be far more conservative and are very willing to take a back seat and let something be proven for them before they'll actually take the leap and implement SDN. But some of the startups that we've paired up with SK Telecom have been in the SDN realm, and they're all on the data center side.
So I'm on the board of a couple of companies in this space. One that's focused on the carrier business, and they have 3 really big deployments already. You guys can hear me. Probably running 50 million subs, something like that, through the system today. So, and it's been operational probably for 2 years now. And it's interesting. At the end of the day, I think the benefit that the carrier has gotten is kind of what you guys are saying. They tried to turn their network basically into a data center. So at the end of the day, they put a bunch of applications on top of it to pool them together and virtualize them so they have elasticity, but they also lowered the cost pretty dramatically. And so in effect, they've turned their POPs into localized data centers for content distribution, for example. That's one application.
I think that's absolutely true, and I think if you were to look further out, you look at carrier architectures. I mean, they've been defined over the last 100 years by the link budget for copper, right? But that's disappearing. So I think, if you look 10 or 20 years out or whatever the time frame is, you're not going to have the same architecture driven by copper link budgets. And what carriers really need is hyperscale data centers for a ton of reasons. But if things are going to be virtualized, their services are going to be virtualized, and the access architectures are going to be different. So I think there's a lot of commonality there.
I think in a way we're all saying the same thing, in that the larger the customer is, the Googles, the Amazons, the larger the data center is, the more prevalent the problem is. But it is limited to, in my opinion, to the very large implementations.
Yeah, I think the carriers they have one thing going for them. They have a couple of things going for them and a couple of things going against them. Certainly, network assets and, real estate assets, and, they build lots of COs with lots of big old equipment, which now can be done in one, machine. They just freed up a whole bunch of floor space. They can do some interesting things with that. That's novel. And they understand being a service provider, which is obvious, but right, that means a 24/7 nationwide operational culture, which is a huge, huge benefit. That's where you see many people coming from the software industry trying to become clouds, failing completely because they don't understand, operations. Or I think the telcos, at least the large domestic ones, and maybe some of the large international ones, they don't really have a software development culture, a modern software development culture akin to what you find in a modern web company. They think, developing software means, getting Telcordia to do something for them, or, flying in 100,000 guys from KPMG or Anderson Consulting or whatever that is. So that is the biggest cultural, internal cultural shift that they have to get their heads around if they want to be successful, in the broader cloud space.
It's interesting. My first job in technology in 1980 was working as a wire wrap technician in a New England Telephone Central office on my uncle's union card. And he skimmed off 30% of everything I made to for being able to work. But anyway, I kind of grew up in and around there, worked at Bell Labs in Andover, Massachusetts. And the level of innovation that I saw early days at Bell Labs and in the phone system really reminds me in many ways of what I see at Google today. And some things to consider. The phone system used to be vertically integrated, and then it was not. And the pace of innovation slowed when that happened. Google has complete control over their stack. When I was on the board of Dune Networks, Google was pressing very hard for that technology. This is in the public domain, and it's years ago now, because they wanted to have their own protocol stack running on scalable Ethernet switching systems based on the Dune technology. And that vertical integration that Google has, even down to the individual optical transceiver level and so forth, makes them a very attractive customer. They spent $3 billion last quarter on their CapEx. But Apple is dramatically outspending Google. And so we're in the middle of an arms race to build up global data center footprint. And a close friend of mine runs the data center footprint build out for Microsoft. They have around 1 million square feet. They're going to expand that to 12 million square feet in the next 10 years. They have the money set aside to do that. And that's going to be a feeding frenzy for infrastructure vendors like Juniper that know how to build stuff that scales. But there are many, many unsolved problems around the IT operations management infrastructure, and it's really going to be the confluence of monitoring and discovery and data aggregation with best-in-class distributed systems on top of what's probably going to be a fairly different infrastructure, hardware layer. Google just announced yesterday a new server architecture based on IBM. I found that to be pretty interesting.
IBM?
IBM Power. You bet.
Oh, PowerPC.
You bet. Absolutely.
PowerPC.
PowerPC. You bet. PowerPC CPU. And so they're looking at, who knows, maybe it's just a way to get pricing leverage on Intel. I wouldn't be surprised because they have none, right? But there's still a lot of innovation happening at all levels of the stack. And it's good for Ethernet as a foundational technology, bottom line.
Just trying to segue off of what Jeff had said with copper, does silicon photonics, are you guys seeing anything out there, or is it still sort of in academia, proof of concept, the price pointing right kind of situation?
I've seen one or two, Intel's been pioneering this. I've seen one or two companies come by lately with attempting to use silicon photonics somewhere in some type of systems architecture. Chris and I made an investment actually together in a company called Diablo, which is doing an SSD on the memory channel, and the real advantage there is ultra low latency. Now, something like silicon photonics could take that even to the next level, where you could think about, sharing much more efficient sharing of, memory. Memory primarily, I would think would be the interesting bit. Memory and disk, in a rack scale, in a multi-rack scale, maybe in a whole data center, certainly within some latency boundary. So I think it's interesting technology. I'm not quite sure that I'd be willing to make a bet on a company that had it, silicon photonics at the core of it. But I've definitely been keeping a close eye on it.
I think that's right. I think silicon photonics, well, so first of all, what is silicon photonics, right? I think a lot of the companies that you speak with would like you to believe it's CMOS and you can make the stuff at TSMC. But most of the companies that are pursuing, I think a better term might be integrated photonics. And it's a CMOS process, but it's not, it's not 28 nanometer TSMC CMOS. It's a different process. But there are, I don't know, maybe 10 or 20 fabs in the world that can do things like that. But that's almost a tangential point. So Chris mentioned that he worked at Bell Labs, and I know that the guys at Bell Labs have been working on integrated photonics forever, right? I mean, it's not a new idea, and they had some pretty novel approaches, but it never really happened. And, you know, I think it's for a variety of reasons. I mean, it's hard to innovate. You really need 3-5 materials for certain functionality, which is not silicon, and you need to combine that with silicon. These are hard problems. They're physics problems, and physics problems usually take longer than you think and take more money than you think, and they have not generally proven to be good investments. But that said, there are some companies out there now that are, I think maybe we're getting to the point where some of these technologies will be mature enough to use in Juniper equipment and others, our peers. And I think these are big markets and big opportunities and hard problems, and some people will solve them. Whether it's a venture space, maybe, maybe not. That's really, it's really a hard area to invest in, but I think they're very interesting areas.
You know, it's interesting, if you take a step back and you look at the photonics industry, it's really fallen out of favor in the past 7 or 8 years with investors, but the whole show is predicated on the innovations on many degrees that industry produced in the late 90s and early 2000s. And if you look at the challenges facing the next generation of modern data center and the next generation of Ethernet, there's clearly going to be a very important role for photonics to play. You know, we're talking about 400 gigabit Ethernet, but it's really hard to do a SerDes faster than 25 gigabits with electrons, right? So I think you'll see a movement towards parallel photonics in the data center. It's already begun with small form factor quad SFP transceivers, a very fine company named, excuse me, having a senior moment here. Kayam is doing some nice work in that area. The challenge that silicon photonics has and will probably continue to have is they have to compete against best-in-class materials and the various functions that make up an optical transceiver. And so I think in the near term, my view is that the answers are probably going to be hybrid photonics with some level of integration on the die. Cisco believes that silicon photonics is a strategic technology. They acquired Lightchip for $270 or $280 million.
Lightwire.
I'm sorry, Lightwire, not Lightchip.
Mellanox
We were the
acquired,
leaders.
Kotora.
Mellanox.
Mellanox acquired Kotora.
Cisco acquired Core Optics, which is